In this lesson, we are going to learn about basics of circular motion. For anything to move in a circle, we need a force towards the center. Remember that. For anything to move in a circle, we need a force towards center. And that we call it centripetal force. If we consider the sun, earth, orbit is elliptical but almost circular, right? So, the force here that is acting towards the center is gravitational force. There is a gravitational force between the earth and the sun. And here, this force provides the necessary centripetal force for earth to go around the sun. The gravitational force between the earth and the sun provides the necessary centripetal force. Right? Sun is pulling the earth. Is the earth pulling the sun? No, it is pulling. Whose force is more? Earth or sun's? Sun's? No. Both the forces are equal and opposite. That is what is Newton's third law. With whatever force the sun is pulling the earth, earth is pulling the sun with an equal and opposite force. Then why does the earth accelerate, not the sun? Actually both accelerate, right? But the acceleration of the sun is much small because sun is much bigger. Acceleration is given by force upon mass. Force is same. Mass of sun is huge. Sun is 99% of solar system. Therefore, acceleration of sun is very less. Sun just wobbles a little bit. And the earth accelerates and goes around the sun. So, for the earth going down the sun, gravitational force provides the necessary centripetal force. If you look at an atom, there's a nucleus. Nucleus, there's plus charge. And there's an electron here, moving in a circular orbit, at least in the Bohr model. Right? Here, the electrostatic force of attraction between the electron and the nucleus. Now, this is electrostatic force of attraction that provides the necessary centripetal force. Suppose you take a stone and tie it to a string and make the stone go in a circular path. In this situation, tension in the string provides the necessary centripetal force. Right? For anything to move in a circle, we need a force toward the center. This is not an extra force. This is some force like gravity, electrostatic force, tension that acts towards the center. Right? Suppose you have got a rotating table. So say this is the top view of the table. And here something is rotating like this. Who provides the necessary centripetal force? Here friction provides the necessary centripetal force. Suppose the table rotates. On that you got a coin. So coin also rotates along with the table. Right? Therefore, here the friction provides the necessary centripetal force. Suppose you have got a well, like you have in a circus, and some motorcyclist is going in a circle like this. Then normal reaction provides the necessary centripetal force. Therefore, for anything moving in a circular path, we need a force towards the center. And that force, we call it centripetal force. Centripetal force is not an extra force. It is some force like gravitational force, electrostatic force, tension, friction, normal reaction that is acting toward the center. Right? One of these forces, any of these forces acting toward the center is called centripetal force. And that centripetal force is given by mv square by r. This is centripetal force, and this is one of these forces.